Good morning, my dear class 8 English version students. I hope everyone is okay and also still fine. In the previous class, we have also explained very important topics for your exam. Here's the important topics. We have also know the law of refraction of light. Here's the refraction of light. We have also one activity. Here's the activity is the refraction of light of the glass slab. Here's the refraction of glass slab. We have also explained the basically three categories. Today I have just selected another important topics and also the interesting topics. Basically interesting topics it's also happened here and there, everywhere and all the time. Yes, today we have also explained the practical application of refraction. Yes, the practical application of refraction, we have also give you the three examples. Basically here's the three examples. First examples, refraction of light. Second examples, virtual image of a coin due to the refraction of light, most interesting. And the third, change of image position of fishes due to refraction of light. Today, okay, please everyone see the books. The page number is 116. First, when a straight rod is immersed obliquely in water and looked at from above, how the part of the rod that is underwater will appear? If you observe carefully, you will see that the rod is appearing smaller, thicker and raised upwards. In fact, it appears to because of refraction. As you see in the figure, light is refracted from the denser medium water into the rare medium air and enters your eyes. Every part of the immersed rod is raised upwards. Again, as a result, the rod appears lifted upwards and reduced in length and increased in diameter. Here's basically, please everyone see the books. Here's one figure. Here's the figure, the straight and the obliquely. When the straight, they have no any chance, but the obliquely, they have the enough chance. Basically, the straight rod. Second example is take a steel mug or a ceramic cup. Put a coin in the mug or in the cup. Keep your eyes in such a position that you just fail to see the coin. If now somebody pours water in the cup, the coin will become visible at one stage. It has been possible due to refraction phenomenon. Due to refraction, light bends in passing the denser medium water into the rare medium air and create a virtual image of the coin which you see. Third, so first example, it's also the straight rod. Second example is the virtual image of a coin due to refraction of light. Third example, did you ever hunt fishes? Does a fish stay at the position at which you see in the fishes in the transparent water? Not at all. In fact, we observe the virtual image of the fish. The fish stays at a position which is a bit lower than where it appears to be. If you hunt the fish with a spear, you have to aim it a deeper and the further position than its apparent position. Something similar happens about the appearance of steps under transparent water. The real position of a step under water is lower than it appears when we look obliquely. People failing to release it may have a fall. Such events you can see if you visit the Sierra Island of Saint Martin. The water there is very transparent. Stones and algae underwater appear much closer to the eye than they really are. This happens due to refraction of light. So, my dear students, today I have also give you the three examples. Here's the three examples. First example is a straight rod. Second example is the virtual image of the coin, and the third example, change of image position of fishes due to the refraction of light. Now, my dear students, again we have also give you the another example. Basically, here's the another example. I also give you the basically a small concept. Here's the small concept. Lesson 6 to 7. It's also the huge concept, but today I have also select the small concept. Lesson 6 and 7. Total internal reflection and critical angle. When a ray of light enters a rare medium from a denser medium, the refracted ray bends away from the normal drawn at the point of incidence of the ray. As a result, the angle of refraction becomes larger than the angle of incidence. In this way, as the angle of incidence increases, the corresponding angle of refraction increases. For a particular combination of such pair of media, there is a particular value of the angle of incidence, which in this case must be smaller than 90 degrees. The corresponding angle of refraction becomes 90 degrees, which means if the refraction ray passes along the surface of separation of the two media, the angle of incidence which corresponds to the situation is called the critical angle. Now, what will happen if the angle of incidence is greater than the critical angle? The angle of refraction cannot naturally be greater than 90 degrees. Today I have also give in the next time I have also explained this figure. Here's the figure, the total internal reflection and the critical angle. I think, my dear students, I have also give you the concept. It has been observed experimentally that in the case of the light ray, instead of the being refracted, is reflected back in the medium from the surface level. Thus, the boundary surface here acts as a refracting surface, and this refraction occurs according to this law of ordinary reflection. This phenomenon is called total internal refraction. This means that the light ray from denser medium in this case is reflected at the boundary surface following the ordinary law of reflection and returns back totally to the denser medium. My dear students, today I have just finished my theory. Here's the theory. Today I have also select basically main topics, the practical application of refraction. Here's the 3 practical application of refraction. I hope everyone take it in the home. Goodbye, my dear students.